Welcome back everyone to Mathnasium with Fulshear. Today we're going to be going over the Pythagorean Theorem as well as its converse. I do have a few examples prepared. Let's go ahead and dive in. So for the Pythagorean Theorem, what it is a relationship between a triangle's sides and hypotenuse. So for instance, for a right triangle, and it does have to be a right triangle, we're talking about a relationship between the triangle's legs, so the shorter sides of the triangle, and its hypotenuse. The equation that represents this relationship is going to be a squared plus b squared is equal to c squared. So for us, the legs of the triangle are both a and b. It does not matter the order or which one is a and b, but the legs themselves are going to be a and b. That means our hypotenuse is going to be c. So if we square those, a squared plus b squared, they should equal our hypotenuse squared. I do have a few examples below, so let's go ahead and use our new knowledge to solve for these equations, or solve for the missing sides here. So for leg of 3 and 4, I'm trying to find my hypotenuse. So to set it up, I'm just going to rewrite my equation. A squared plus b squared is equal to c squared. And I'm just going to go ahead and plug these guys in as a and b. So let's say I have 3 squared plus 4 squared is equal to c squared. Now all I have to do is just square them and add them together. So 3 squared is 9, 4 squared is going to be 16, and again that equals c squared. 9 and 16, that's 25, is equal to c squared. And then I'm not looking for c squared, right? I'm looking for c, because that's the hypotenuse length. To get rid of the squared, all I'm doing is taking the square root of both sides. So the square root gets rid of the square, and it leaves me with 5 is equal to c. So 5 is our hypotenuse. Now, if we think about this, if I take the square root of 25, yes, it is positive and negative 5 as an answer, but can a length be negative 5? No, a length are always going to be positive. So our length for the hypotenuse is going to be positive 5. So that's how that works there. Now for our other example, we have the hypotenuse and we're looking for a leg. So again, we're going to start a squared plus b squared is equal to c squared. But this time, instead of having both legs, we have our hypotenuse, our c. So let's just put 12 for a, so it'll be 12 squared plus b squared is equal to 13 squared. 12 squared, that's 144, plus b squared is equal to 13 squared, which is 169. So if I subtract 144 from both sides, I get b squared is equal to 25. And actually the same thing we got from the other one is b is going to be equal to just 5. Now what we're going to do is we're going to go into the converse. So the converse says, well, what if it's not a right triangle? Can I still use Pythagorean theorem to help us identify what type of triangle it is? Yes, we can. So as we've just been talking about, a squared plus b squared equals c squared, that is only for a right triangle. But what happens if c squared is less than or c squared is greater than a squared plus b squared? Well, if c squared is less than, it's going to be an acute triangle. That means all of the angles are going to be less than 90 degrees. If c squared is greater than a squared plus b squared, then it's going to be an obtuse triangle. That means that at least one angle is going to be greater than 90 degrees. So an example like this is we're going to figure out kind of what triangle we have, and we have to have all 3 sides. In this case, 4 is the largest number, therefore that's our hypotenuse, so that's going to be c, and both of these 3's are going to be our a and our b's. So let's just write a squared plus b squared, and it does something with c squared. Right, so let's go ahead and put those in. We have 3 squared plus 3 squared. Again, we don't know what's going to happen just yet. That's equal to 4 squared. So 3 squared is 9. So 9 plus 9 is going to be 18 is something, then 4 squared, which is 16. And we all know that 18 is going to be bigger, right? So if a squared plus b squared is larger than our c squared, that makes this an acute triangle. Hey, thank you so much for joining us. to go over the Pythagorean Theorem and its converse. We look forward to seeing you next time. Have a good day.